today we are going to perform the experiment, and the name of the experiment is the modulus of rigidity for an torsional pendulum. We are actually going to find out the modulus of rigidity of this wire by using this experiment. This is the very easy experiment. First you have to remove this disc. Okay, take the weight. Just I am removing this disc from that. Okay, this is the check nut, and I am going to put on the balance. Okay, you just take the weight. Now weight is near about 1 kg to 1.218 kg. Now I am just putting this wire into that disc. Okay, and this is the check net. I am fully tied for this. Okay, this is the one check net, and this is the another check net. In between you have to fix the wire. It should be very tight. It should not remove. Okay, so now once fix this, your experiment is ready for the performing. Okay, but before that you are just finding the weight of this. Again you have to find out the diameter of this. We are just measuring the diameter of this. It is near about 12 centimeter. Here, first reading here, second reading in this fashion, third reading in this fashion. Okay, take the 3 to 4 readings, and you have to write down the 4 readings, add it and divide by that 4 readings. You will get the mean diameter of this, and once you get the diameter value, divide by 2, you will get the radius of this disc. Observations: you just least count of the micrometer screw gauge. You people knows this is the screw gauge, micrometer screw gauge. Okay, so now these are the main scale inside that. You just see here, and it's the screw gauge. Okay, here main scale reading is on the center rod. Okay, and its least distance between the one line is the 0.1. Whatever the circulation scale, you just see here 10, 15, 90, 20, 100 scale means 0.1 divided by 100, and your least count of this screw gauge 0.001 centimeter is the least count of this. And by using this, you have to find out the 5 position. This is the first position, diameter of this wire. Okay, now reading is that it should be in this fashion. Okay, you remove it. Now your main scale 0. Okay, right now 0. Whatever the circular scale is 72, main scale is 0, CSR circular scale 72, and now the diameter of this will be the A, means 0 plus C plus bracket this 72 multiplied by its least count, and then whatever the value you will get this diameter. In this fashion you have to take the 5 positions reading of this wire, 1, 2, 3, 4 and 5. Okay, then you just find out the mean, that you will get the diameter of this wire, and once you get, then you can start directly taking the reading of that. Okay, this part is only for the observations. Okay, now actual experiments we are going to start to performing here. So you just see here length observation table, length of the wire in L centimeter. How to measure the wire of this? You just take this from this to this. You see here, it is near about the 48 centimeter. Okay, so you have to write here 48. Okay, and once you write the length, then one more important thing is that once you fix this length, you have write here fixed length. Now you give apply the sum of the force, apply to the force in this fashion. You remove force. Okay? This should not be move in this fashion. It should be circularly rotate to that. Okay? Now we are starting the reading. First one, 20 oscillations. Now I am applying the force to that. Okay. This is the okay. Now once I will remove my external force, the time will start. One oscillation. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, stop this now, 20. For the 20 oscillations, you will get the 4.04 minutes. Okay? Now, stop it. This is for the T1. 3 times you have same length, you have to repeat this oscillations time period for the 3 readings. Okay? Now, fixed length, one has already taken the reading. Again, apply the force. Again, take the reading. This is the second. Again, I will get the force 4 point something. Okay? Second and third. Again, I am applying the force and start it. Again 20, again 4 point something. So now here length is whatever the length you are 48 centimeter. T1 4 point something minutes. Here 3 times. Now you have to calculate the mean of this. This you have to add and divide by 3. Now calculate the in second only, not for the minutes. Okay? 4.06 minutes you have calculated in second. This second, you add all this value divided by the 3 readings and you will get the mean. Okay? Now, period. This time taken for the 20 seconds is whatever the mean time you will get for the 3 readings divided by the 20 oscillations and you will get the period, total period T. Okay? And once the square it, whatever the length divided by the T square and this values comes here. Okay? For that second reading you have to just reduce the length. How to reduce the length? 4 centimeters you have to reduce. And you have to measure the length. This is the 1, 2. It is near about 42. Okay, 6 centimeters I have reduced. for this second length is 42 centimeter. Again you have to give the oscillations for T1, stop it for the 20 oscillations. Again you have to apply the force for second time for the same length and measure the time period for the 20 oscillations. Again you have to apply the external force to the disc and again measure the 20 oscillations time period. Again second reading, again you calculate the main T, again you have to calculate the period T and T square and L by T square. And once you have to take 5 to 6 reading for that, for the different lengths and oscillation, measure the time period of that oscillation, and lastly you will get the all values L by T you have to calculate and calculate the lastly the mean of this. Okay, once you get this value, before that applying the formula that time, now once you calculate the mean of that L by T square, okay, then come to the actual formulas for that. Okay, first you calculate the moment of inertia of this. Okay, how to calculate? You knows the mass of that, you knows the R of that. R means what? R is nothing but the radius of disc. You have to calculate radius of the disc and the mass of the disc divided by 2, you will get the I, means moment of inertia. And once you will get, then you have to apply the main formula. Eta is equal to 8 pi. What is this is the I means moment of inertia, and this L square. L by T square value is there. You have to separate this L by T. So this nothing but the 8 pi I means moment of inertia divided by this R, and R is nothing but the radius of wire. Okay, wire, and it's power 4. Okay, you have to calculate this first bracket, then put the values of this L by T square into here, and you will get the theoretical value by practical value. Now you have to plot the graph. Here is the length, here is the period. This is the length and time period T square. Okay, once the plot, you just draw the line, find out the slope of that, the L by T square, and you have to put for that practical calculations, you have to put the actual value of this mean value L by T square. And for that graph, you are just replace this mean value into L by T square by the slope value. 8 pi I R raised to power 4 multiplied by whatever the slope you get from this graph. You have to put the value, and then you will get the modulus of rigidity of this stainless steel wire. Easily you can calculate. Okay, this is the way. Thanks for, we have finished this experiment, and thanks for you people.